You're going to take your Arduinos and you're going to program the most up-to-date node software for the RotorHazard timing system. You can find that on the RotorHazard GitHub page. We'll have links. So this, from here on, this might be just a slight visual, but you can easily just program it using the text manual that we've got online. What we'll show you is when we talked about the unconventional way of programming these, we were actually talking about taking this board and this board and just kind of holding them together. Now, what you'll see here on these FTDI boards is there's a ground, usually a CTS or DTS pin, then your 5 volt or 3.3 volt, your TX, your RX, and your DTR pin. What you will try to do is you will try to match them up. Now, what usually happens is these boards will actually be lined up this way. And you can also see on the back of some of these FTDI boards, the silkscreen will actually tell you what pins are what. So when you look at the Arduino, you'll see you have, they call this BLK, but this is really ground. You'll also have your CTS, which is also typically ground on the Pro Minis anyway. And you'll have VCC, which VCC in this case, in this board, because this is a 5 volt Pro Mini, not a 3.3 volt Mini, you would switch your board over from 3.3 volt to 5 volt, and you would match up that to VCC. And then you'll see that TX, RX are actually switched on the Arduino board. You want that because you want the transmit from the FTDI board to go to the receive of the Arduino, and the transmit of the Arduino to go to the receive of the FTDI chip. And that way they can communicate back and forwards. Just think of it like a regular road for vehicles. And then the last one is DTR. And again, usually on these boards, that's typically ground. Because really all you're going to need are ground, VCC, TX, and RX. Now, the real way of doing this is you would actually solder wires to and from here, and then you would desolder the wires once you're ready to put them on. Now, you don't have to clean out the solder from these holes. The only thing is, if you do it the solder way, because you can see on the actual RotorHazard board here, the one that Sleeping Dog Tech sells, you can see that there's also pins right below it. This is where the chip would actually lay down, and you would notice that if there is solder on the bottom of these and they extend way too far out, you could short them on here. These pads are only meant for the long rectangular ones with the holes through them. They're only meant for the RX 5808s. They are not meant for the Arduinos. So even though you've got a fair decent amount of room between the two different boards, you want to just make sure that it's not overhanging too much, because sometimes if you're a little happy with the solder and you're putting it on, it'll look like it's fine up on top, but it'll keep seeping down underneath it, creating a long glob underneath. So the unconventional way that we have been programming our boards, and a lot of you out there can definitely criticize this, this is not a good way of doing it, but we've seen this done in the past by other people, is you actually just slide the board on in the right spots, remembering that VCC has to go to the 5 volt, your TX goes to the RX, and your RX goes to the TX. But you'll notice that there's a little bit of slop here, and unfortunately, sometimes if you don't have it in the right spot, you won't provide a good contact. But if you notice on our FTDI board, this pin, or all these pins, are a little bit bent this way, away from the board. And that's because what we do is we put the Arduinos somewhere in the middle, and then when we program the chip, we'll actually take and we'll squeeze this together just ever so slightly. Remember, you don't want to like really grip it together, or else you'll really bend the pins. But what you're doing is you're actually preloading these pins against the pin walls of the Arduino. Now, the reason why we say this is not a great way of doing this is because, one, you're going to fatigue these pins over time if you keep doing this. So if you're doing hundreds and hundreds of these, yeah, this is not the preferred way of doing it. The other way, or the other thing is, this doesn't always provide a good contact. You have to preload it just enough that not only are you not breaking your boards, and you're not breaking the internal connections in here, but you're getting a good enough contact against these pins. And the reason why we do it this way is because you'll contact one side on the back here, but you'll contact the other side on the forward side here. And the second part is, or sorry, the third issue with this is if your finger accidentally touches the wrong thing, you might end up causing a little bit of an issue on the board. These do get a little warm if you keep them on too long. So when we typically do the board, we will insert it in here. We will load up the Arduino software, the Arduino IDE. We will open up the sketch. We will change all the settings. Again, look at the manual online. It'll show you which settings to use for this. We will compile it, making sure that it actually will work. If it throws an error because of memory size, don't worry. It'll fit all onto the board. And then right before we put this on, we'll connect the FTDI connector to our computer, making sure that the 5-volt is turned on. We will slide this into place, and we will preload, and then we will hit the flash button. And it only takes about 20 seconds for it to actually load. And what you can actually see is if you've done it correctly, there are LEDs on board which will flash very furiously back and forwards when it's actually doing it correctly. Sorry, not the Arduino board, but the FTDI board. There's actually two LEDs on either side, and that's actually showing you the RX and the TX line connections. The ones in the zeros going back and forward. Zero obviously being off, one being flashing. So this will flash back and forward all the time. If you don't have a good connection, this won't actually flash. The only reason why it flashes is it's transmitting to something and it's receiving information from something. So it does go through send a lot of information to the board, and then it'll receive a lot of information verifying that it's actually flashed correctly. So what you want to just double make sure is, again, enough pressure here that you're not doing any damage to the boards, but you're making good contact here. And this way you can actually cycle through all of your boards at once, because the software is agnostic. It doesn't care that you specify what number node this is. That's why we've actually pre-numbered it into the board. We use a series of grounding pins on these chips, or on these boards right here, and the software will actually determine that this is 1, or this is 5, or this is 8, depending on which position on the board it is. So even if you were to remove one and replace it, if one happens to die in the field, the software will always be like, okay, this position right here is node number 4. So quickly do that, and then when you come back, we will actually start to prepare the pins. We will load them into place. We will put the Arduinos on board, and then we will solder everything on.